Hi, my name is Su-Chen Huang. I'm Associate Professor at the Department of Electrical Engineering of Taiwan University. Welcome to the first lesson on fundamental of solar PV energy. Here's the outline. First of all, I will make a brief introduction about major energy sources. Then we will take an overview of PV systems, and then down to PV cells and modules. And we will discuss about the relationship between power and energy and how to calculate these values from voltage, current, and time. Finally, we will talk about the characteristic of PV modules, and we will check out a data sheet and try to find out the test condition and all the performance parameters. There are various forms of energy, including mechanical energy, thermal energy, electromagnetic energy, electrical energy, and chemical energy, and also nuclear energy. The energy can be converted from one form to another. For example, the nuclear power plant, which is a thermal power station, typically we will use a reactor, nuclear reactor, to generate heat and then produce steam. And the steam can be used to drive turbine, which is connected to a generator to produce electricity. Energy sources can be classified into non-renewable and renewable energy. For non-renewable energy, it is finite or limited in supply. Renewable energy, however, can be reproduced, and also sometimes it's a natural phenomenon such as sunlight, rain, or wind. Most of the energy sources, non-renewable energy source, is fossil fuels. For example, coal, gas, and oil, which have limited supply. The problem of those non-renewable energy is when you generate power, you need to burn it, and the gas released will affect the environment. Scientists think that it causes climate change and pollution. Nuclear, however, is clean and efficient, but the problem is the safety issue. There are growing amount of renewable energy to produce electricity. The reason for that is it's eco-friendly and less pollution. The example are geothermal, hydroelectric, solar, and biomass. From this table, we can see that in 2010, the yearly solar fluxes, it's about 3,850,000 exajoule. Exajoule is 10 to the power of 18 joules. So compared to other renewable energy and also non-renewable energy, the amount is huge. So that is the reason that we should focus on solar energy. Solar energy arrived to the Earth in two forms. One is solar thermal, and the other is solar photovoltaic. Solar thermal generate heat to warm up our water, so we can get hot water at home. The solar photovoltaic, which convert the light to electricity. Photo is relating to light, voltaic relating to electricity produced by chemical action in a battery, which is named after Alessandro Volta, which is an Italian physicist and chemist. So let's focus on solar energy. Let's take an overview of PV systems. From this slide, we can check out the purpose of PV systems. First of all, PV module generate DC electricity. The generated electric energy can be used right away or stored in the battery for later use, or converted to AC electricity and then either used by home appliances or is exported to the utility grid. So here are the pros and cons of PV systems. The PV system is renewable energy. It's inexhaustible. However, it depends on whether the performance can be lost during a cloudy day or rainy day. It requires very little maintenance, hence its low cost. However, it needs a high initial cost. It's about $3.18 US per watt. It's easy and fast to install on the house, and it requires sufficient spaces. For example, a 3 kilowatt hour solar system required 15 meter square spaces. It's free energy, so we can reduce electrical power bills. We can use that for multiple applications. However, so far the solar modules is low in efficiency. For monocrystalline cells, the efficiency is about 15 to 20%, and for polycrystalline, the efficiency is around 13 to 60%. But it's good for the environment. It can save about 0.5 kilogram of carbon dioxide emitted into the atmosphere. So it's still worth to invest in solar systems. And in this figure shows the discrepancy between power demand and peak PV energy production. Typically, the peak PV hours are around noon, but at a household, the demand are measured in evening time or in the morning time. So it's better to have the battery storage. We can store the energy during the peak hour and use that later to save the electrical bills. So there are two types of PV systems. One is on-grid or grid-tied PV system. The other is called off-grid type. For grid-tied PV systems, it's on-grid, so it's can interact with the grid. And in that case, we can install a bi-directional meter, so we can save electricity to the power company when we have excess or extra power generated from our solar system. The other type is called off-grid PV systems, which sometimes we call it as standalone or it's an independent system. So typically it will be installed in a location with no access to electricity. And it requires energy stored in batteries. So it can be installed anywhere, but the cost, of course, for battery banks will be higher for the initial investment. So we have the basic idea about the energy sources and how we can use that to build PV systems. Now let's go down to the cells and modules. PV cell, a solar cell or PV cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect. A single solar cell produces about 0.5 volts of electricity and up to about 8 amps of current, depending on the type of the cell. Silicon solar cells are metallized with thin rectangular shaped strips printed on the front and back sides of the solar PV cells. This metal content is called busbars. It will conduct current generated by the solar cell. And the thinner metal, which is perpendicular to the busbar, are called fingers, which will help to collect the currents. 5 busbar cells are currently one of the leading trends in solar systems. And the higher number of busbars reduces the effective finger length between the busbar, which decreases finger resistance losses, as well as the impact of micro cracks. Frequently, solar cell busbars are constructed from copper coated with silver. The silver coating is necessary to enhance current conductivity as well as lower oxidation. Just as in the battery connection, the solar cell can be connected in series to increase the voltage. So, for example, if we have 3 cells in series, each of them is 0.5 volts. Overall voltage will increase from 0.5 volt to 1.5 volts. Similarly, we can connect the solar cell in parallel. So the current will be 8 amp. So for example, if one cell have the current of 8 amp, the overall cell still have 0.5 volt, but the overall current would become 24 amps. So it depends on the requirement of the system. We can either connect a module or cell in series to increase the voltage, or in parallel to increase the current. So we connect 60 or 72 or even 96 PV cells to form a PV module. And then put the PV module either in parallel or in series to form the PV panel. And then we have the array constructed in the overall system. PV module is formed by several layers. Solar cells are laminated between transparent EVA films and then coated with tempered glass for protection. And it has waterproof material on the back. And edges are sealed with waterproofing and anti-corrosive aluminum frames. Finally, a junction box is attached at the back to provide electrical connections. This is a typical junction box. Inside that, there are diodes and also connections to connect the module, the cells in the module together. The diode is one directional electrical device. It can only allow the current flow in one direction, but block the flow in another direction. Usually cables with Mc4 connectors are at the end of the box. And the junction boxes have at least an IP65 rating or even have IPCC 7 rating. The 6 represent the grade of the protection, which is dust protection. And 5 from the table 2 means that it can sustain the low pressure water jet from all directions. If the grade is at number 7, that means it can sustain the immersions in water between 50 centimeter to 1 meter for 30 minutes. So all junction boxes with an IP65 rating will provide protection against dust and low pressure water jets. There may be limited ingress inside, but it won't stop the component from properly functioning. The solar junction box with an IP67 rating will provide complete protection against the dust and will properly function after temporary immersion in water. Just as I mentioned previously, there are diodes in the junction box. In addition to that, we need to put extra diodes to either serve as blocking diode or bypass diode. The blocking diode allows the flow of current from the solar panel to the battery, but prevents or blocks the flow of current from battery to solar panel, thereby preventing the battery from discharging. Bypass diode is used in case one of the panel of multi-panel strings is faulty. It bypasses the faulty panel by providing current an alternative path to flow, and thereby maintains the continuity of power production. Okay, so typically in a junction box, there are 3 diodes to bypass the string. So in case there's a cloud or shading spots in the solar module, the current will be bypassed. So therefore, we can still use the panel. So in this case, there's a leaf on top of the string, but still we can use 2/3 of the module to generate power. As for the Mc4 connectors, it is MC represents manufacturer multi-content. It's currently doubly electrical connectors. 4 for the is represent 4 millimeter diameter contact pin. It's a single contact electrical connectors, commonly used for connecting solar panels. Mc4 allows strings of panel to be easily constructed by pushing the connectors from adjacent panel together by hand, but required a tool to disconnect them to ensure they do not accidentally disconnect when the cables are pulled. And this figure shows the Mc4 female and male couplers. And there is a website that in the YouTube. There's a YouTube film that you can check out to see how they are assembled. But later in our class, we'll teach you how to do that. And in addition to the connector we just showed you, Mc4 connector also provides wire connectors, which will allow the panel to be connected in parallel. In this section, we'll discuss about the relationship between power and energy and how to calculate that. Energy is the quantity property that must be transferred to an object in order to perform work or to heat the object. So if you want to leave the box, you need to provide the energy. Lifting the box faster will change the amount of power, but not the amount of the energy. So power is different from energy. Power is the rate of doing work, the rate at which energy is used, produced, or transferred. So we can represent the power as this equation, which is E divided by T. E is the energy in joules, and P is the power in watt, and T is time in second. And this rectangle show you that the relationship between E, P, and T. So for example, we can multiply the power by time to get the overall energy. A conventional power unit called horsepower is defined that if you want to lift an object which is 75 kilogram up for 1 meter in 1 second, the power is called horsepower, and it's equivalent to 735.5 watts. But in our system, we are more interested in the electrical power. And typically, we can calculate the electrical power by using this power voltage current triangle. The instantaneous electrical power, P, delivered to a component is given by P of T is equal to V of T times I of T. And P represents the instantaneous power in watt, and V is the voltage or potential difference across the component in volts. And I is the current with the component in amps. So if the power is positive, that means the component is consuming power or absorbing power. If the power is negative, that means the component is supplying power instead of consume that. So for our the PV module, it is power supplier, but for the load, it will absorb power or consume power. Here are examples in our daily life. For example, a hair dryer. The power rating for hair dryer can ranging from 800 watts to 1800 watts. For the light bulbs, from traditional one to LED, can ranging from 40 watts, 11 watts to 7 watts. So we have the idea about the power consumption. How about the energy? The electrical company charge you by the energy, not by the power. So if you want to calculate the energy, which is power times the time. So use the electrical light bulb as an example. For 40 watts light bulb, if you light on for 3 hours a day, and for a year, the overall energy is about 43.8 kilowatt hour. So remember that the energy, the power, the unit for power is watt, but the unit for energy is watt times hour. So if 1 kilowatt hour is cost you $0.11 US, then you can calculate the annual cost for the light bulb. In this case, it's $4.82 US. How about the power rating for the solar panel? Typically, the solar panel output power is ranging from 250 watts to 360 watts. Depends on the model or the type of the module. So you can calculate if you know the voltage generated or current generated from the PV cell, you can calculate the power. For example, if you have a solar module, it will generate 32.5 volt and 8 amp. Then you can calculate the overall power generated, which is 260 watts. So you can calculate the annual energy produced if you have one solar module. Of course, if you have multiple, then you can multiply by the numbers. So from the previous example, we can calculate the daily energy produced per module. So, which is the overall power produced by the module multiplied the daily active hours. So, for example, the sun shine about 4 hours, and then you can calculate the overall power or energy generated for a day, which is about 1 kilowatt hour. And then multiply that by 365 days per year, then you get the 379.6 kilowatt hours. So if you know the demand, then you can calculate the overall number of modules that you need. And this will be discussed later in the different lessons. Okay, so we know the concept about power and energy. How about in the solar energy system? There are two terms. The first one is called irradiance. Irradiance is power generated from the solar system. Insolation, however, is to the energy. Irradiance is an instance measurement of solar power over some area. And the unit is watt per meter square. So typically in a bright sunny day, if you consider the area of 1 square meter, the power generated from the solar is about 1 kilowatt. So later we'll talk about the testing condition, which is defined as 1 kilowatt per meter square, which is considered as the solar standard condition, which is sunny without cloud. Insolation is a measurement of the cumulative energy measured over some area for a defined period of time. So, for example, you can have daily insolation, monthly, or even annually insolation. And the common unit is kilowatt hour per meter square. Of course, it has to be specified the period, just as I mentioned, maybe daily insolation or monthly or annual. So how to determine the solar irradiation rate? Actually, it depends on the times of day. In the noontime, of course, we have stronger irradiance. In the morning or even the evening, the irradiance is weak. It also depends on the season and the geography. So there's a way to describe the irradiance for different locations. The term is called peak sun hours. It's a measure of the available daily solar resource. The term is hours per day. And it's known as insolation, depends on the specific geographic location. The definition is the number of hours of global average solar radiation normalized with respect to 1 kilowatt per square meter. So the formula is peak sun hour, which is equal to the GASR divided by 1,000. So do not mistake peak sun hours with available sunny hours. So for example, you have 6 hours of sunny time, but but sometimes it's cloudy and sometimes it's sunny. So you have to translate that in the bright sunny time or sunny hours. So sometimes if you do the translation, it may be equivalent to 4 peak sun hours for the day, not 6 sunny hours. So as conclusion, 1 peak sun hour is equivalent to 1 hour irradiance at 1 kilowatts power. 5 peak sun hours means we would have 1 kilowatts of power for 5 hours. Here are some online sources of solar data. You can check out the insolation of your location from those websites. Finally, in this session, we're going to check out the characteristic of PV modules. Here is a typical IV characteristic of PV module. In a bright sunny day, the irradiance is about 1 kilowatt per meter square. But when it's cloudy, it can be as low as 100 watts per meter square. And this curve shows you the module current with respect to the voltage. A standard test condition for solar module is defined as the operating temperature of 25 degrees Celsius, solar irradiance of 1 kilowatt per square meter, and the atmospheric density of 1.5. And this is considered as a bright sunny day with a moderate temperature. However, in realistic, the operating temperature is high. It can be as high as 45 degrees Celsius. And if you consider the cloud and wind, the solar irradiance may be degraded. So those normal operating cell temperature is defined the testing condition is defined as 800 watts per square meter, and with the same the atmospheric density of 1.5. So the overall performance is about 85 to 90% of STC. it is a more realistic field conditions. So typically in the spec of the module, you may have the spec given in these two conditions. And here is another example, which is the Panasonic PV module. So the rated power, which is P maximum, is 340 watts. And you can see several numbers, for example, maximum power voltage, maximum power current, open current voltage, open circuit voltage, or short circuit current. So let's take a look at the IV and PD characteristics of PV module. So the orange line represents the IV curve. From the curve, on the right-hand side of the voltage, which is the open circuit voltage. Since it's open circuit, the current is equal to 0, but the voltage is the maximum, which is, in this case, 71.2 volts. And the other term is called short circuit current. Since it's short circuit, so the voltage is equals to 0, and the current is the highest one, which is 6.02 amp. And then you can multiply the voltage and current to have the power with respect to the voltage. So you can see that there's a peak or the maximum output power. So we represent that this power is P sub MP. And this maximum power, the voltage in this case is 60.3 volts, and the current is 4.64 amp. So if you multiply these two terms together, you will get the maximum output power. In this case, is equivalent to 340 watts. And from the data sheet, you can also find the IV curve with respect to irradiance. So the current is almost linear to the irradiance. However, the voltage stay almost the same. And there's another important coefficient, which is called temperature coefficient. It is quite important because the output power is degraded at higher temperature. So we have negative temperature coefficient for P max and also the voltage. Although we have positive coefficient for the current, the overall of power still have negative temperature coefficient, which means that in a bright sunny day, although you have more power generated, but due to the temperature coefficient, which is negative, then the power will be degraded. So from the data sheet, you can also see there's a module efficiency, and we can actually calculate the number according to the spec. So first of all, we need to define the efficiency. The efficiency is the power output divided by the power input in percentage. So to get the number, first of all, we need to figure out the area of the solar module. And here in this table, we have the dimension. So you have the length and width. So the overall area is 0.674 square meter. And then we calculate the power since the overall power, the maximum power is 340 watts, and if you divide it by the area, you get the output power, which is 203 watts per square meter. And remember that for the standard test condition, the input power is equal to 1 kilowatt per meter square. So calculate the efficiency, you get the overall efficiency is 20.3%. Okay, so this concludes the lesson of this section. And if you are interested in the material and you want to have further study, here are the references.